Hi everyone, I'm Yuan Tong. We are Group 5 from the Civil Engineering Department. Our members include Chengwei, Yushen, Yifan, and I. Our topic is Structural Design with Artificial Intelligence. This is our outline today. First is our motivation and background. In structural engineering, structural design is to decide what sections that the beams and columns are going to use, like the middle figure shows. It is an iterative process where we start from giving a design, then we perform the analysis of the design. After that, we evaluate the design based on the analysis result and try to make a better design. However, the design space is very large, making the design difficult to optimize. As a result, in this project, we want to use AI to find an optimal or nearly optimal structure design. For literature review, there is some research using genetic algorithms and reinforcement learning to design a truss system. However, there is seldom research on the steel structure design, especially in the full-scale structure. So in this project, we would like to use AI to design those challenging steel structures. So we form the structural design problem as a series of searching decisions, where for simplicity, we design the sections in story level, which means the columns and beams in the same floor will have the same section, like this figure shows. Totally, there are 5 sections for column and 9 for beam. So in this problem, each floor of beam column should have one section type assigned, and the most important element, like the first floor column, will be decided first. Then after all of the elements are assigned with a section, we can get the design score, where the score will be based on the material usage and the structure's strength. For this design problem, we propose using MonteCarlo Tree Search, genetic algorithm, and reinforcement learning to solve the problem. In MonteCarlo Tree Search, each depth of the tree will be a beam column element that we are going to design. For each node, its child node means the sections that the next element can select. For the implementation, since the tree will be very big for depth 21 and for the many section choices in every node, we use a linear decay C in the UCB function for faster convergence and avoiding too much exploration. Finally, we can get the MCTS design, which is quite good. Next, in genetic algorithm, we represent structures design as a chromosome code. J is a cyclic process where we start from generating random structure populations. Then we calculate their fitness and select the good structures from the populations. After that, we will do the crossover and mutation to generate the new populations. Then J will keep going like this circle. For the result, after 100 iterations, we can get a slightly better result than MCTS. The appearance of the structure looks similar to MCTS since it's near to the optimal design.
Finally, we also form our problem with reinforcement learning, where we mainly focused on deep Q learning network. Our agent is a structure designer, and the environment is the structure analysis simulator. In our case, state is the design of the structure, while action is the beam column sections that the agent can select. After the agent takes actions to choose an element section, the environment then will give a design score as a reward. How to design the reward is important. We propose 3 calculations for our problem. First calculation, reward is simply the return value of our environment. Next calculation, we want our reward more related to the influence of each action. So in this version, our reward is the difference between the present score and the previous score. For the last version, we reverse to DeepMind's paper and clipping the reward to 1 and -1. Right-hand side figure shows that comparison between these 3 types of reward calculation. As you can see, difference and clipping have better performance and less training time, which means that the difference of score is better to learn policy compared to whole structure score. We also implement different tricks to improve our result. We have implemented the double DQN and noisy net concept, but sadly, due to the time limit, we can't have a more detailed and complete result and conclusion. We are still on our way to exploration, and this is a big joke related to reinforcement learning. And here's come to conclusions. Reinforcement learning is able to use less time to find a solution, which is better than MonteCarlo Tree Search and genetic algorithm. And it also shows the potential to design the different shape structure simultaneously while others don't. Reinforcement learning can really tackle our problem. And thank you for your attention.